In neural threads, a modular robotic arm learns to repair itself after simulated damage during a live test. Objectives target minimal downtime, quick reconfiguration, and steady grip while the network rebinds, with measurable downtime reductions and robust recovery under unexpected loads. The method mixes real-time damage, sensor fusion, and a self-repairing controller rerouting tasks through intact modules. Results show the arm regains nearly full strength within seconds, verified by a precision pick and place sequence. Experts discuss safety, transparency system explainability, and scalable self-healing as the future of field robotics.